Good afternoon, Jan. We
Good
are
morning, Michael.
we are back on Discord. Yeah, I'm
Yeah,
not sure
act like
what Discord did in the interim, but yeah, it was completely messed up. So yeah, we had to improvise the
mm,
last couple of times. But
yeah, there was something wrong because when I logged in, I saw a lot of funny things. Um, they probably just installed an upgrade.
yeah, yeah, yeah. Pretty much every time I open it, it's like 15 upgrades, and then the
Mm,
little spinning Mickey Mouse pants. I know it's supposed to be a controller, but it looks like Mickey Mouse pants.
mhm.
All right. Well, yeah. So
They
yeah, last
they
time
probably
we
they probably defined agents to do the updates.
yeah.
Put them in a pipeline.
Yes. Yes. Well, an important part about creating a pipeline of agents is that you have to have validation steps.
Mhm.
Yeah. So.
I had a look at I had a look at your Pluralsight course.
Oh, good. Yes.
For the moment, I ended halfway.
Okay. Yes.
Actually, it's very short and
Yeah.
it's very dense.
Yeah.
It's only 55 minutes, but don't finish it in 55 minutes. There
Yeah.
is a lot of information there.
Indeed.
Uh,
Indeed. It was supposed to be 45 minutes. That was. Yeah. That was like we want a really short, advanced course that
mm,
covers. Yeah. All these things. It's like okay. I'll try that. Um, yeah, and for the first few modules, I was right on the time budget that I had set aside for myself, and then yeah, the last two modules just
mm,
boom, you know. But yeah, so you haven't yet made it to the big demo.
no.
The big demo is in module 3, and that's where I take kilo code and I build several different agents and then run an orchestration that goes through each of them, and that's the part that has the validation steps. So in addition to having the agents, I also defined a workflow document that
Mm,
that told the orchestrator how to run those agents. So
mhm.
it told it to insert validations at these stages.
Yeah, but it's remarkable. Every step you set, you do, you review,
Mm-hmm.
and actually, like you said last time, they cannot be AI cannot be accountable.
Right.
So in fact, you make a team of agents, but every time you have to check to review,
Yep.
much more than with humans.
Yeah. Exactly. Exactly. This is
Mm,
not how I organize a team of humans. Yeah. I extend trust to humans. I do
mm,
not extend trust to agents. Um, and yeah, if somebody makes a mistake, then we have a conversation about that mistake. Was it that I was unclear? Probably the case. Was it something else that you need? Some training,
mm,
some assistance. Are you stretching yourself too far? All those questions that you have to
mm,
have with a person. And then when you have that conversation with a person, it sticks. when
mm,
you have that conversation with an AI, it says, "Oh, I'll do better next time," and then that context is flushed, and it doesn't do better next time.
mhm,
So basically, that conversation with the AI turns into, and now update the skill or the agent
mm,
definition or the instructions or the workflow or whatever it was that led it to that
mm.
behavior in the first place. Have that
Yeah.
conversation, update that thing, try it again. Yeah, it's like iteratively developing an application itself, except it's running on a non-deterministic machine. So you can't really be sure
Mm,
that it's going to follow the instructions as written.
mm. But you, what I did before, I every time I add on, and I never erased from the context.
Yeah, yeah,
While you regularly, you say, okay, I add it to the knowledge, and then I erase the whole context. I start from scratch with the new guidelines.
yes.
But in the end, is it not going to use more tokens that way?
Oh, it absolutely will. Yes. Um, yeah. So I'm not optimizing for token use, at least not initially. Um,
Hmm?
and in fact, when you see the big demo, the kind of the outcome of that is I show you how much it costs to run that demo. And
Okay.
when I showed that to some of my friends, they're like, "What? It costs $40 to do that?" And so, well, yeah, but now we are optimizing from 40 down to, how low can you get? 5? Um,
Mm.
versus versus trying to start cheap and then improve until you've got the quality, and you're not going to get there from that direction. So you have to keep the quality bar high. Go ahead and spend those tokens, and then you can optimize down, see how cheap you can get it. But yeah, the main thing that I'm fighting against is context pollution. So so yeah, if you continue within the same context, then yes, it has some of the information that you want for the next task, but then it also has a lot of other information. Um,
Yeah.
there are there are a couple of different uh, you know, behaviors that have been measured you know, scientifically. One of them is there's a paper called "Lost in the Middle." This is a fantastic paper that that measures filling up the context with a lot of information, and then asking about some information that's within that document. And so they start with a small document, and then it can reliably answer anything, any question that you've got in that document. As it gets bigger, it's more it's more reliable answering questions about things that are at the beginning or at the end. But then, as the information it needs is toward the middle, the reliability goes down. Um,
Okay.
and so and so that's one thing that I'm fighting against is I want to keep the information that it needs short, and I want to make sure that um, that there's no extra information that's hiding it somewhere in the middle. So
Okay.
so yeah, start a brand new one, load in just what's needed for that new one, and then go on to a new task.
Okay. That's that's good advice.
Yeah, and that's the sort of thing that you get to a little bit later in your journey. Right at first, it's like, wow, amazing, this stuff works, um, and I absolutely want you to to experience that. The um, the place that I got to after the amazing this stuff works was then looking back on what it did and seeing ways in which it fooled me. So this is now my theory. I'm not really seeing the research to support this yet, but my theory is that these machines, especially through the um, uh, reinforcement learning process, um, these machines were uh, basically optimized to pass the Turing test. So reinforcement is that phase after you've given it a bunch of raw data and just asked it to predict. Then you have um, a certain task for it to do. You have certain outcomes that you want rather than just raw predictions. And then you go through another training pass where you're changing the weights less significantly than you are during that first pass, and then you're rewarding it for these behaviors or punishing it for bad behaviors. So the reinforcement pass that ChatGPT was built to facilitate is it producing output that people like? And so they have the thumbs up, thumbs down button on ChatGPT, and they release it
Mm.
to the world, and then millions of people flood in there and then start using it. Some of them actually hit the thumbs up, thumbs down, um, but then there are also other signals that they could mine. Did somebody continue the chat, or did they abandon it at that point? Abandoning could mean they got exactly what they want and they can move on, or it could mean that they gave up on it. So that's a uh, that's a little bit of a noisy signal. But then you could also have a smaller model that's evaluating the sentiment of the conversation, and if the conversation is going well, then use that as a positive. If the user's getting mad, use that as a negative. And so through that reinforcement cycle, they basically tweaked the model to do things that people respond well to, do things that people liked.
Okay.
Essentially, trained it to pass the Turing test. And the Turing test is, can a computer fool somebody into thinking that it's not a computer? And so my theory is that these things were trained to fool people, and researchers are people too. I've seen some research that I look at it and say, wait a minute, I think it might have fooled you there. And then I see it certainly within the hype. I see people who are promoting hype that have been fooled by the output, and they're saying, look, isn't this wonderful? And then you take a look at it and you're like, it resembles something that's wonderful, but it's got some serious problems with it. So that's that's where I am right now. I'm really trying to keep my own confirmation bias low, which is really hard. When it does something that looks really good and it produces code and that code works, and then going back and thinking, well, could it have done anything different? Is this falsifiable in some way? And then seeing if I'm being fooled.
Okay. Yeah, it's. But last time or the time before, you spoke also about the cutoff date of this training.
Yeah. Yeah. So that they go through this process in multiple times, multiple passes with different models. So whenever you get a model, the initial training set was cut off at a certain point, and then they did the training, and then they did the reinforcement learning, and then you get to use the model. So. Yeah.
But why don't they train permanently?
Yeah, that's one, because that's expensive. Two, because that's harder to predict. And three, you get the behaviors that you want without permanent training. So yeah, the context in which we were talking about that was using a library, and that library has evolved over time, and so its training set includes all the different versions of the library, and so without any additional direction to constrain its predictions, it's going to just kind of average over all of those, and then at a certain point, maybe a new version of the library was released, that information's not in the training set at all, and you have to wait for the next iteration of the model. So continual training, as in let's keep the pipeline running, let's add more things to the data set, and let's put things in there. It means that that you're doing that expensive part all the time, and the economics don't quite work out where it's really expensive to train one, but then you get to reap some of that value over time. So you really want to train and then use that model for a long time. Reinforcement is a kind of an additional step. So it's it takes a trained model and then it increments it. It moves forward from there.
You specialize it in something.
Yeah. So that step is a lot less expensive, but then in order to specialize it in something, you have to give it good objective functions. You have to give it good evaluations and good examples, and so that's not as expensive in terms of the energy and the compute, but it still takes time to validate those evaluations, make sure that we're actually producing good results. So that's kind of that quality pass, and so that does require human intervention as well. You can't just keep an evaluation running forever and expect the quality to continue. In fact, trying to remember if there was a paper that demonstrated this. After yeah yeah as reinforcement learning continued, the quality started to diminish. So it's like, okay, reinforce just up to this point, and then we're good. So I'll have to go back and look and see if that's a thing that actually exists, or if I'm just misremembering.
Kind of overfitting.
Yeah. What's really funny is, overfitting is a problem in machine learning and small
Mm.
numerical models, and uh, so we apply that term, and it still means something in large language models, uh, but yeah,
Not
it manifests
exactly
a
the
little bit
same.
differently. Yeah,
Yeah, yeah.
yeah yeah it's kind of, these things have so many degrees of freedom that it would
Mm.
be pretty much impossible to give it so much data that it overfits. Um, but yeah, you do still have some degradation of quality as you add more data. And yeah, oh uh, there's a YouTube channel. Um, I'm trying to remember. Welsh Labs. Yeah, he has been doing a series on large language models and neural networks, and uh, and this is all building up to, he's actually got a book that describes how all of this works,
Mm.
and so he's been publishing different parts of the book as videos, and then uh, but yeah, the last one that I watched showed a curve that let's see, yeah, at once you've reached a certain amount of data, then it starts to make really good predictions, and that starts to level out, and then it starts to fall off, and then when you talk about smaller models, then yeah, that correlates with the overfitting portion. You've yeah, it's memorized the data, and it's not seeing patterns anymore, and so it's making bad predictions. And so people usually stop there and they say, okay, back up. That's where we want to be. We've hit the top. But that curve continues down. It has a nice long tail, but then it starts to slowly creep up, and in some cases, it comes up to even higher than the original peak. And so he trained a very small model and showed us exactly what was happening inside of the weights, and
Mm.
explained why that happens. Um, and that was that was a really good description. So from a very small model now to a large language model, we're seeing um, we're seeing similar shapes. I don't know if continuing to train them will get us back to a point where now it's making even better predictions, but that would be really expensive to do that.
Mm. And you don't know the outcome.
Yeah,
So
yeah.
that was, you said Washlab, the
Welsh Labs,
W.
WELCH. Let me YouTube.
Washlabs. He has a website and
Yeah.
on YouTube.
Yep. Yeah. The video I was talking about is called Grokking.
I think I saw some of these videos. You see, I'm forgetting faster than I learn.
Mm-hmm.
um, I have to watch them to be
Mm-hmm.
sure, but I think I saw some of his videos. Uh,
Yeah. Yeah. Grokking was just
mm,
a really, yeah, that was a really well done video. I mean, all of his stuff is really well done, but
mm,
that one especially, it's like it's so rare to have one presentation that is mathematically precise and builds intuition.
mm,
That's just really hard to get right, and he nails that.
mm,
So he's like, these are the equations. This is what we're starting to see. This shape that we're starting to see. And here's a function, and you look at that function. That's what it's approaching, and this is why it would approach that function, and then this gives you that intuition of as it sees more and more data, that the pattern starts to outweigh the memorization. I was like, well, yeah, okay, yeah, that makes a lot of sense.
Yeah. Actually, that's the advantage of YouTube. There are so many channels, but there are even quite a number of good channels, especially in mathematics,
Yeah, yeah,
where they make things intuitive. I said, why I went to that course before. Now they explain it so well.
yeah,
Um,
yeah. 3 Blue, 1 Brown, and the calculus series. Like, yeah, if they had only taught calculus that way, so much more sense.
and and of course, now there's so many possibilities to simulate things and to visualize them, which 40 years ago they didn't exist. So
Yeah,
at the time they could only draw something on a blackboard with some in white. Now
yeah,
you have all these computer simulations, so
yeah.
it makes it easier to understand.
Indeed.
Good. What did you have for today?
Yeah, yeah. For today, I wanted to continue the conversation that we started last week, where we were talking about skills, and building custom skills in order to direct what the LLM was producing. So today, I want to show you the skills that I developed specifically for Janaga.net and Assisticant. So this is fun stuff. Right, so we want to go to here, and we want to share this on the Zoom.
Let's hope that Zoom is working this time.
Yeah.
Should be.
Okay, so that is shared. No, we're not going to update right now. Okay. Okay, so let's kind of review where we are. I've been working on this notebook for the view model. Yeah, we got that. Okay. And so it brings in several different NuGet packages, and it also brings in Nawiis core DLL. Let's go ahead and run them all, make sure it's still working. And then Nawiis core DLL defines some of the model, and this continues it from there. So the idea is that I'm testing out model ideas, visualizing the whole model here, but I can quickly change the things that are kind of at the bottom of the graph, because the code is right here. But then once I'm really happy with it, then that moves into the DLL.
Oh,
yeah. Yep. So demonstrate an inspector and their set of weights. Demonstrate an inspection where we have brought some available weights, and we're inspecting a scale that has a scale specification and identification. And so we tweaked this so that we've got different capacity ranges. So right now we're a really really narrow scale, 1500 to 2000. And then what does it produce? And so we're in this version we're seeing that it was producing a 50% that was less than the minimum, and we test drove our way into fixing that. So if I do in a .NET build, actually I probably will need to to reload the window so that it completely unloads the DLL. And then I should be able to do a .NET build, and we should see a fix to that. Now to get there, we did things like the running tests skill and the test data generation skill. And then I think we even have some commands here. Yeah, so red, green, and refactor, TDD commands. Okay, so yeah, now I was able to rebuild, and so I think if I run all, then I should see that this one goes away. At least that's what the unit tests told me. So let's see if okay, what are you doing? Oh, okay. I was just impatient. There we go. Yep. So, yep, now it is gone. So, so yeah, with this process, explore with the notebook, and then test drive with the DLL. So there are some additional skills here, like right here in Janaga. There is a skill that is a guide for working with Janaga in the Nawiis application. So it talks about creating facts, saving facts, querying facts, and it's got separate documents for each one of these. Some advanced patterns that you'll use every once in a while. Reactive view models, so we can go very, very specific into how we can use Assistant in order to create these reactive view models. And so, like if I go into creating facts, then that's this this document right here inside of the skill. Usually it's inside of a references folder, so I should probably rearrange things. But yeah, this talks about we're using the fact type. We're defining a record. We talk about immutability, and then some best practices. So nice short little reference of information there.
Yeah.
Querying facts is where we get into the given match successors. Things like where current, successors of type. So some of these things come from Janaga extensions. So all that information that you would need to look up, basically, if you're doing this. But the upshot of all that is that if I come over here,
why not just point it to the website, to the documentation on the website? Because that's too big for the context.
Yes. There are a number of different reasons. So if you were to load the website in, first of all, the website is HTML, CSS, and a bit of JavaScript. So it's actually quite a lot of JavaScript. No, it's static site. So yeah, the React stuff has already been stripped away. But but yeah, there's a lot of fluff, a lot of extra format that just makes it look good in a browser. But this is just raw markdown. So that's one thing. The other thing is that this is using progressive disclosure. So the website is organized differently. It's organized for a person to kind of navigate through and learn. If the website were broken down to this level of detail, you would see a very short page and a whole bunch of links. Go to that link, then you'd see another very short page, this one's actually not very short, but this one's more on the long side. But yeah, it wouldn't really be optimized for a person to read it. Yeah, this is optimized for the agentic runtime to read it. So the way that the runtime uses this with the model, remember the model is just next word prediction with some extra reinforcement training so that it can follow instructions. And so the excuse me, the runtime gives it the instructions to look at this this document, and here's the task you're trying to complete. Which of these resources are going to be helpful for you to complete your task? And so then, based on the task, it'll come back and say, well, I'm doing some UI integration. So yeah, I'm building a Maui application. So let's go ahead and load that up. And it says, okay, here's that information and the task that you're trying to achieve. And here's all the tools. What do you want to do? Oh, I want to call that tool to edit some code. So it's going through several iterations where it's showing piece by piece parts of the skill. In fact, even before it gets there, it says, here's the list of all the skills and their descriptions. Which skills do you think are going to be useful? And it says, oh, that one looks interesting. So it iterates through. And so if it were to go to a website in order to do that, it would be making a call out to the website each time versus having it all local. And so that also reduces the latency.
And so on the website, it would need to absorb everything first, while here it can just dig deeper.
Yeah.
And specialize it in what it needs at that moment.
Yep.
Is that correct?
That's correct. Exactly.
Okay.
Yeah. So so let's see if we can give it a task here. So we've got we've gone through just the the required weights. Let's say now that an inspector wants to be able to add their own weights. So so I'm looking to see, do we already have a fact for that? And I don't think we do. So this is going to require it to do a bit of
Yeah. For example, an easier one. So you said it needs 50%, but it also needs, 2,000 parts and 500 parts. So a part is actually the maximum divided by the E value. The E value was the step. So for example, if we have a 60,000 kilo and it steps by 50 kilo, so the display increment. So then we say, okay, 60,000 divided by 50. Yeah, so you have 1,200. That's the number of parts. So we need to include, was it 500 parts and 2,000 if they are within the range.
Okay. So to get there, let's first of all change our scenario a bit. So we've got the scale specification is going from 50 to 2,000, and so for that, the mandatory test points are inside of the compiled DLL. So in order to iterate to that, I could do some test-driven development to iterate toward it, or we could iterate inside of the notebook. So let's start with iterating in the notebook. because we haven't seen that yet. So that means that I want to load in the inspection view model, and I want to generate the mandatory test points. And so let's let's pop that out there, and so we've got create test point. Yeah, I want to do this. I'm just going to turn these into turn these into just top level functions here. So I can create a test point, mandatory test point. Okay. So just make sure that compiles. That compiles. All right. So yeah, we are in cursor. I could continue inside of the notebook. That wouldn't really be taking advantage of what cursor can do for us. So Control Alt B opens up the little side window. Control N, start a brand new chat. And so first of all, I want to ask, and well, no, for this we'll go straight to agent. Basically, what I want to do is I want to do the same thing here, but now with the generate mandatory test points. So produce the table of test points using that. So that should be enough, just with what it has here, to add a new cell here that calls that function. Let's see. Planning your next moves. Come on, gotta warm it up here. There we go.
Yeah, it's very cold at your side.
Yeah, it is. Yeah, I need to put a few tokens on the fire just to get things moving.
What's the temperature outside?
It is actually now above freezing. So yeah, it is. Yeah, in Fahrenheit 37 degrees. So I guess in Celsius that would be like 2 degrees maybe.
Yeah. Okay, that's still reasonable. And a lot of snow.
We got snow earlier in the week, and it just never melted. At least not on the places where people aren't driving. So yeah, my driveway is still a sheet of ice. So I was trying to get out there and see if I could get Jenny to work, and I was like, I can't even reliably get my car across this ice. It's just going to slide into the retaining wall right behind our house, and I was like, I'm not going to take that chance. I was thinking, what would a smart person do? Not this. Okay, so it created this cell here, produce a table of test points. So calls generate mandatory test points from this scale specification projection. Which does produce that table. Yeah, so I think actually that's that's a good starting point. So that's our test setup. Not test setup, but our we're checking out what it can do here, and so now at this point, what you might do is continue in this session. It's already loaded a bunch of information from from the notebook, and it kind of has a feel for what the notebook looks like. So I'm going to stick with this session. Yeah, I don't think that anything's gotten poisoned. Okay, so now what we want to do. What was this kind of a high level description of what we wanted to do?
Yeah. So now we have the minimum capacity, the maximum capacity, and also 50% of the capacity as test points. Actually, we need to add 500 parts and 2,000 parts. And a part is the maximal weight divided by the indication step. Yeah. But I think just now you will change the range from 50 to 2,000. I think it's better to increase that range a little bit, because otherwise these values are not going to be in.
Yeah. All right. Couple orders of magnitude.
No, make it like 60,000. 60,000, which is a common value.
Okay.
Yeah. And so that we didn't have a separate for the indication step and a minimum here. Or do we? The display.
Let's see.
So the smallest step that the indicator, the display, can change. And the minimum value that we can use to weight something.
Okay. Well, yeah. So let's start there. So I will cut that, and so we want to add to the specification 2 more properties. Yeah. So add to the scale specification, and so we want the minimum step, you said?
Yeah, the minimum step, we usually call it E, the value E. It's a small e.
Okay. Yeah, how about we just do that so it knows specifically that, and that's the minimum
Sorry,
step.
but that's the common language of my customers. Yeah. So that's the minimum step of the indicator display.
Okay.
And then we have a min value, this MIN, and that's the minimum weight that it can display. And then we have the maximum, but the maximum you already have.
Okay. Okay, so what it says here, capacity low, is that the same?
That should be the min, and the capacity high should be the max.
Okay.
So then capacity low to min.
And max.
Yeah. Capacity high.
Ah. T. High. Okay.
Hey, but you had verification divisions. What was that in the model? Verification divisions. Was that not?
I'm not sure where that came from, actually. All of this was originally driven from the business process overview and the calibration workflow mapping, which were 2 documents that I generated by looking at the old code.
Yeah. And where does it? Verification.
Yeah. So how about let's hold that. We'll go over to a new one. Yeah, that's holding on to that. So then we will ask, and then we'll say given the calibration workflow and business process overview, what are verification divisions.
Verification division, yeah. So I don't remember using that word in the old software.
Yeah.
So
So mentioned once under setup phase in form header. So it is referencing the VB
yeah,
code.
yeah.
The inspector records the customer detail scale and scale specifications.
You have the scale interval E, the verification scale interval E there. Yeah.
Yeah.
So then verification divisions. Okay, number of verification scale divisions often defined as max plus E. Max divided by... Oh, no. Max divided by E. Okay. Okay, that's what I mentioned. So max divided by E is the number of parts.
Okay.
So that one, yeah, how to say, if for example you have a max of 60,000, you have an E value of 50, so you have this number of divisions 1200. Oh, yeah. So
Okay.
500 times that, or 2000 times that are values that we have to inspect.
In fact, I will get a little bit of...
I don't remember what was the official name for that. No, I don't have. Yeah, here it is in French. I don't have the English version. Nombre d'échelons de vérification. That's the official naming.
Okay. So that's probably where it just directly translated to verification divisions.
Yeah. Probably long ago I used that term in my software, and that's why. Okay, let's call it parts for the moment.
Yeah. So that's the number of those.
It's max divided by E. Yeah.
Okay. So then I'll paste in a little bit of context about OIML. So this should, yeah, that's related to what we're talking about here. So I will then end this off with the task that I want it to perform. Update the model. Do not. Let's see. Yeah, here's the... Yeah, the scale specification is not in here. The scale specification is in the code. But that's okay. It's got access to core as well. So in that is called Nawiis core. Yeah, here's models, inspection model. So yeah, do not worry about backward compatibility. Yeah, it's often very worried about making changes in a way that that aren't going to break things. And I have to constantly remind it, no, we're in the stage where it's okay to break things. Nobody depends on this.
Okay. It's amazing that it takes that into account.
Yeah, I think it was. I think that is part of the prompts that Cursor gives it. Um,
Mm.
so yeah, we talked about the raw training. We talked about the reinforcement,
Reinforce.
and then that last part is that when you now use one of these models inside of a tool, the tool provides kind of a framework of how it's going to give it prompts. So
Mm.
that that framework of using skills, of saying these are the list of skills. What are you gonna do? That's deterministic code running inside of Cursor that says look in the skill folder, pull out the descriptions, create this this text, and now that becomes the next prompt.
Mm.
So part of that code probably has a set of instructions that says look out for breaking changes,
Mm.
which is usually the right thing, but not always. Okay, so it is making changes. So in fact, we are seeing those changes in the test model and everything. So what I was hoping to see somewhere up here, we've got different files that we're exploring. Some of these files, so here it's loading in the view models. Sometimes it will tell you very explicitly that it is using a skill. So it looks like it is well into looking at the actual files themselves, and it's not telling me that it loaded a skill. Or sometimes I even see it use the term it learned a skill.
Mm.
Yeah, not seeing that. So it could be that it went entirely on the shape of the nearby code, and it said, okay, match that structure. But yeah, with the proper skills in place, it will also it'll also use those skills in order to generate new code. But yeah, here it's trying to run tests. Let's go ahead and restart. See if just want to make sure that it's not having any issues with building. It looks like it was able to build just fine. Oh, it may be because oh no, I did say debug here. Yeah, I should probably change this to release, and then that way when it does its work over here, it's probably working in debug mode and it's not going to get locked. That's a good idea. In fact, let me do that right now. Oh, I made that change, and it got swept up in, oh, the model made these changes. No, that was me. I'll keep it. Okay, and it's actually running through a test fixing loop. Okay. So now these are the files that we modified. Let's go ahead and start with the inspection model and see what changed. And so it changed capacity low and capacity high to min and max.
Mm.
It changed, it added E, and so it still has string accuracy class. So yeah, and it took out verification division. So let's keep that. Yeah, so now let's see how it's using those. So changed all of the various test helpers to use those proper names. But yeah,
Seems to be
it
okay.
looks like that's all that it did here. So I'll keep that file. And here are the test data helpers where we actually change the names here. That's fine. This is where we should be getting into...
Min-max
Yeah.
E. Okay, that's fine as well.
Yeah. So
and we have the parts. Yeah.
Yeah, and it computed it as a double.
No, that should be an integer.
Yeah, so parts should be an integer. And we want to round down, round up, round to the nearest.
Normally there is no rounding to be done in real world.
Oh, okay.
Max will always be a multiple of E.
Okay. Okay, so yeah, since we have to account for things that might fall outside of that, we'll just tell it to do. Yeah, I think maybe telling it to round to the nearest, that'll also take care of any rounding errors. Yeah.
It's actually in the definition screen form of the scales that we should protect against that. But
yeah, and in fact, the model is set up for doubles for min, max, and E, so maybe those should be integers as well.
Yes.
Yeah. Not sure what would the best way, because actually some of the weighing instruments are very small precision weight scales for lab use. So we are talking about what is it, milligrams, micrograms even. Okay.
I don't know whether it exists in micrograms. I should look up the data of my customers.
Yeah.
But then you have the big weight bridges for trains, for example, which is in tons, thousands of kilos. So the customer, I always let them choose between kilogram, milligram, so that they have a unit with not too many numbers behind the comma. Actually, the way I stored it in 1999 was everything in strings. That's not a way to go.
Yeah. Okay, let's keep that. But yeah, this value now, 0.1, is not not
that
a
was
good.
the verification scale, I think. No.
Yeah. So now this should be the E value.
Yeah.
So going back to inspection model, the scale specification, that's E. So for a scale of this size, would that be somewhere around 10 kilograms?
Well, you can take 10 there, yeah.
Okay.
I think usually it's 20 and
okay.
take a minimum of 100.
Okay.
Something like that.
All right. So let's just see if I'm going to be able to... yeah, so now that we are doing the release, I will do another .NET builds. And yeah, -C release. There we go.
Test. Yeah, I take that first test. Oh no. The typical values are E20, the max 60,000, and the minimum 400.
400. Okay, let's go with that. All right, and it was able to build the release version, so we should now be able to run them all. And the squigglies should go away. All right, so defining some facts. Okay, and now we have 40,000, 60,000, E is 20, and then that's what we are producing there, and that's what we're producing here. So now we should be able to
Go back to the other
back
context.
to this one. Yep.
Mm-hmm.
Oh, no, I did that in this context. Yeah, I think it's probably safe to start a new context at this point. There's been a lot going on in both of those. And so now that we've got parts, what we want to do is have a mandatory test point at 500 parts.
parts and 2,000 parts. If they are in between these values.
All right, so 500 parts and 2,000 parts.
Mm-hmm.
If they are in between min and max. And it's going to say, I have no idea what you're talking about, but I will figure that out from context. So I told it to pay attention to this file right here, which I probably should have hit save on before I did this, but it can see it in the buffer. It doesn't need it to read it from disk. And so now I found the notebook cell that has the calculation. Okay, adding those. So, it's changing the inspection view model as well as the notebook. So, yeah, here it just added that to the notebook. Yeah, so I should have been more explicit and say, change only the notebook. But yeah, now it's going through and adding tests for it and all that stuff. And running the tests, making sure that everything works. Meanwhile, I'll go ahead and hit run all here, and we'll see if the new inputs show up. Yeah, there's our new inputs.
Okay. So there we are.
Yeah.
That's great. So we have the 10,000, we have the 40,000. That's very nice.
Mm-hmm. Yeah, that appears to be working.
Mm-hmm.
So, yeah, that's yeah. So I guess what we really covered today is more the using notebooks and code together. So yeah, that works pretty well.
Yeah, because he even went back to the code which was in the core DLL already.
Yeah.
And modified that.
Yeah.
Yeah.
Yeah. Added our mandatory parts there, and added tests to make sure that they were all good. Yeah, that's good stuff. Keeping all that. And saving it. And committing it.
Mm-hmm.
Points. 500 parts and 2,000 parts.
Mm-hmm.
And push into main because we haven't started the PR cycle yet.
Mm-hmm.
Good. Good. So the what I have.
If now we change the max to, let's say, 30,000.
Okay. So let's go back to here.
Max to 30,000.
Yeah, I see. So this is going to mean that that this one falls outside of the range.
Yeah, because we don't have a test for that, I think.
There we go. Yeah, at the very least, this code did, because it's verifying that it's within range before adding it.
Yeah.
Yep.
Yeah. Okay, that's great. Was that something that was specified somewhere?
Yes, that was part of this one. Define mandatory tests at 500 and 2,000 if they are between min max.
Okay.
Yeah.
Okay, so that is working. Well, that's great.
Yeah. Yeah.
But so, in fact, for this type of things, we should add a small test then.
Okay.
I don't know. Would that be reasonable?
Yeah. Well, it did add when it exceeds max. So it asserts that it does not contain the 400. Yeah, so it does have scenarios for those various combinations. But yeah, absolutely, you do want to make sure that it does all of those. So I'm going to ask real quick: are there any other related to mandatory test points that we should cover with tests? And I like to do this in ask mode because this is the sort of question that if you're in agent mode, it might go ahead and run those tests, because it interprets that as your intent to write tests. And it's like, no, my intent right now is to review what you come up with, and then I will tell you specifically what I want to add. So, yeah, add a test for the order of the test points. Equal to max, no duplicates, equal to min max. The 500 below min, I didn't see that one, so yep, good, you caught that. Full test of 5-point types. Yeah. Overlap of the 50.
He got that from the original software, because indeed you need at least five points, and otherwise the inspector has to add manually points.
Yeah.
Okay.
Yeah, so I like all of these. Yeah, so add all of those tests. Or, yeah, it'll figure out that I meant to say tests. But yeah, it even gives us a priority. Yeah, and so sometimes I'll say, we'll just do the high priority ones. But yeah, in this case, they're all good. Yeah, and for this, we're not going to need to do the TDD cycle because all of these tests should already pass. We're not testing new behavior. It's just we don't have good behavior coverage at this point. Yeah. Oh, maybe one of them will fail. I was just thinking about the the order in which it adds the 500 and the 2000. I think it adds the 2000 after the 50%, and so that's making an assumption. So let's see what it comes up with. All right, all the tests are passing. So yeah, now it says order by, which would pick up this this case that I was just thinking about. But I'll ask anyway just to show what I was thinking. Would there be a scenario where the 2000 point test is less than the 50% test?
Yeah, if max is even much bigger.
Yeah. Yeah, it happens when max is bigger than 4,000 times e. It actually did some algebra. That's kind of cool. So this test is already in this situation. Okay. When all 5 points test in range. Because it now returns ordered by target weights. This ordering is handled. So yes, it's possible. Yes, there's a test for it. Yes, it's handled. So
Okay.
Very nice. I'm liking what I'm seeing.
It's not accountable, but it's good.
Yep. Yep, very true. Okay, so yeah. Let's keep that. Let's keep that. All right, that's everything. Okay. That mandatory test points are ordered. Yeah, so there is a little sparkle button. You can generate a commit message. Sometimes I'll do that if I'm feeling lazy. But in these cases, I wanted to make sure we captured the intent of the changes. Otherwise, it'll go through the detail of the changes.
Okay.
Yeah. Oh, yeah. Should keep that so. But it's already... Oh, no. Okay. It, well, it says that it's changed. Is it really changed? I don't know. Let's go ahead and amend that. Just to be sure. And push it. Very nice. Okay, I think we've got a process that we can continue to follow. So yeah, following this, we'll kind of gradually build up the logic and so the yeah with tests and the work that you've done on the user interface. Now we should be able to at some point say, okay, start using this view model for that user interface, and it'll rewire all of the bindings in order to bind to the view model. And so yeah, before we do that, we'll want to ask: are there any things that are done in the in this view model that are not covered in that view model? And close those gaps first with proper tests, and then shove those things in. So that's kind of the idea.
Not bad.
Not bad at all.
We had another thing. Next week we are the 5th. Okay, next week I will be there. The week after, the 12th of February, I will not be there.
Okay.
I will be the whole day in a training. So.
All right. Well, I might have an announcement to share about Janaga Cascade at that point. So, yeah, I'll work
12th.
to
Okay.
I'll work to get Cascade ready for launch. so I can
The
do
big
a walkthrough.
pipeline.
Yeah.
The big pipeline.
Hmm.
Mm. Yeah, that's another amazing product.
Yeah, yeah. It is so fun to create a product with this style of development.
Mm.
It's just yeah, yeah. I've tried out different techniques while doing this. So one of the techniques I just recently tried out is the B-band method. So you might see things about the B-band method online. It's a very new library um, that basically builds personas inside of your inside of your agent system
Mm.
that emulate a UX designer and an architect and a product
Mm.
manager and then uh, creates a collaboration. Um, and yeah, at first BMAD was like, hey, this is doing something that's amazing. I didn't even know that this was possible, kind of collaborating among
Mm.
all the various personas. And then took a step back after okay, I finished a program increment using BMAD. Said this is wonderful, and then revisited it a little bit later, and it's like, wait a minute, no, it fooled me.
You're all
It
fired.
fooled me. Yeah.
Mm.
So yeah, I still have BMAD installed, but I am on the cusp of firing them. Yeah.
Mm. What is it? It's called BMAT?
Yeah.
MAT?
Yes. Yeah. BMAD. Um,
Yeah.
the author is Brian Madison, and so it's
Okay.
yeah, it's really named after
It's,
him, but he gives several different bacronyms for what it might actually mean. Um,
I thought a band of mad people.
yeah.
Okay.
But yeah, so maybe maybe one of these conversations I'll show what BBAD does, and we can be amazed at what it does and that it actually works, and then can talk about how it might fool you
Okay.
and how to protect yourself against that.
Yeah, there are still some surprises to come.
Yeah,
Yeah, it's only the beginning of artificial intelligence.
yeah, yeah,
The world will be completely different in 10 years time.
absolutely,
Mm.
absolutely. And yeah, I should be retired by then, so maybe that's not a bad a bad time to let that go.
Wow. Wow. We will see.
Yeah,
Okay, Michael, have a good day.
thanks,
Keep
Sean.
warm and see you next week then.
Indeed. See you next week.
Okay, bye bye.
Bye.